Hello everyone, welcome to my YouTube channel. My name is Bhumika, pursuing the degree of Electronics and Communication Engineering in Sri Venkateshwara College of Engineering, Bangalore. Today's video is about the subject Network Analysis. In this subject, we are going to talk about the topic Superposition Theorem. The superposition theorem states that in any linear bilateral multisource whose response in any branch, if casual to algebraic sum of the response obtained by considering calm source acting separately by making all after source set equal to the zero, where the voltage source are made zero by short circuiting it and the current source is made zero by open circuiting it. The proof for the superposition theorem, where considering the network as shown below by taking two loops such as I1 and I2, where applying KVL to loop 1, it gives Z1 into I1 plus Z2 into I1 minus I2 is equals to voltage, where Z1 plus Z2 into I1 minus I2 into Z2 is equals to V, where I2 is considered as I, where I refers to the current and Z1 refers to the resistance and V refers to the voltage. And the next step is Z1 plus Z2 into I1 is equals to voltage plus current plus into Z2, where the current I1 gives V plus Z1 Z2 divided by Z1 plus Z2. Consider this as the equation number 1. Now we have to apply KVL for the loop 2. We know that I2 is equals to I from the loop 1. So let us consider where near the Z2 we have an arrow mark towards downward which refers as the Ix. So Ix is equals to I1 minus I2, where it is equals to I1 is given as from the equation number 1 V plus I2 V plus I into Z2 divided by Z1 plus Z2 minus I, where Z2 into I and Z2 into I will be cancelled. We are left with the equation V minus Z1 I divided by Z1 plus Z2 is equals to Ix. This is the equation number 2. Now, applying superposition, considering one source at a time. For the case number 1, let us consider voltage source and set current source as to 0 by open circuit. As we open circuit, we get the I dash is equals to V by Z1 plus Z2. The case 2 is considering the current source and making the voltage source 0 by short circuiting the circuit. By using current division rule, we get I double dash is equals to Z1 by Z1 plus Z2, which is equals to minus I. Also, we know the superposition actual current where Ix is equals to I dash plus I double dash, which is equals to I dash minus I double dash, which is given by Ix is equals to V minus Z2I divided by Z1 plus Z2. This is the equation number 3. As we got the previous equation from equation 3 and 2 of the current source, hence the equation 2 and 3 is proved as the superposition theorem. Now let us take a numerical on superposition theorem. The numerical for superposition theorem is to find the current in 2 ohm resistance connected between the terminal A and B using superposition theorem. As you can see in the circuit, we are given by the 5 resistor and 2 voltage sources. Now let us consider 2 voltage source and make 4 voltage source to 0 by applying short circuit. Now case number 1 is to apply the KVL for the loop 1. Let us apply KVL for loop 1. We have totally 3 loops which are named as I1, I2 and I3. The loop for loop 1 is equals to I1, where 2I1 plus 12 into I1 minus I2 is equals to 0 is equals to 2. By simplifying the equation, we get 14I1 minus 12i2 is equals to 2. Let us consider this as the equation number 1. Now applying KVL to loop 2, which is equals to i2, where i2 plus 2, i2 minus i3 plus 12, i2 minus i1 is equals to 0. By simplifying this equation, we get minus 12i1 plus 5i2 minus 2i3 is equals to 2 is equals to 0. This is given as the equation 2. Now applying KVL for the loop 3, which is equals to i3, where 2i3 plus 2 into i3 minus i2 is equals to 0. By simplifying this equation, we get minus 2i2 plus 5i3 is equals to 0. This is known as the equation number 3. By applying matrix to this equation 1, 2 and 3, we get I1, I2, I3. The I1 is given as 0.518 amps. I2 is given as 0.437 amperes. I3 is given as 0.175 amps. Now, we all know that I dash is equals to I2 minus I3. By substituting the values of I2 and I3, we get 0.262 amps. Now, taking the case number 2, as we have to take 4 volt source and open short circuit the 2 volt source, where by applying KVL to the loop 1, we get 2i1 plus 12i1 minus i2 is equals to 0. By equating this equation, we get 14i1 minus 12i2 is equals to 0. This is equation number 1. Applying KVL to loop 2, we get i2 plus 2i2 minus i3 plus 12 i2 minus i1 is equals to 0. By equating this equation, we get minus 12i1 plus 15i2 minus 2i3 is equals to 0. This is equation number 2. And applying KVL to the loop 3, we get 3i3 plus 2i3 minus 2i2 is equals to minus 4, where by equating this equation, we get minus 2i2 plus 5i3 is equals to minus 4. This is equation number 3. Applying the matrix for the case 2 for the equations 1, 2 and 3, we get I1 as minus 0.35 amps, I2 as minus 0.40 amps and I3 as minus 0.96 amps. And we know that I to the power n is equals to I2 minus I3. Substituting the I2 value and I3 value, we get the answer of the I power n is equals to 0.55 amps. In this video, today we have learnt about the statement and the proof of superposition theorem and its numerical. I hope this video was interesting and useful to you all. Let us meet with an interesting topic in the next video. Thank you. Have a nice day.